Welcome to Fun Python Projects. In this video, we'll be looking at the Fibonacci Sequence Generator. If you're a mathematician or so, you probably have come across, or even a computer scientist, I'm sure, you probably must have come across the Fibonacci sequence. So in this video, we're talking about a Fibonacci Sequence Generator, and we want to see how we can write code to generate that. So first of all, the Fibonacci sequence is a series of numbers where each term is the sum of the two preceding ones, typically starting with 0 and 1. So this creates the pattern. So I mean, starting with 0 and 1, right? Every subsequent number is the sum of the previous two. So 0, 1, right? Then 0 plus 1, you have 1. 1 plus 1 is 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. And so on, continuing infinitely, all right? So it is named after the Italian mathematician Leonardo of Pisa, known as Fibonacci. The sequence appears frequently in mathematics, computer algorithms. It even appears in nature in the formation of leaves and animal, body shapes and all that. So we find Fibonacci sequence in mathematics, computer algorithms, nature, and art, from the spirals of shells and sunflowers to the branching of trees and the structure of galaxies. In fact, its simple recursive rule and connection to the golden ratio, which is approximately 1.618, make it uh, make it a fascinating and fundamental concept linking mathematics and the natural world. In fact, I once read in a place where this whole idea of golden ratio is used to measure to see how perfectly shaped people's faces can be and things like that, and then it now leads to being able to measure beauty, how beautiful someone is, and all that, right? Okay, so how do we generate Fibonacci sequence? You already see what it is like. So 0 and 1, and then you add like that, add the previous one, you get the next one. So we can have an iterative version of it. So for the iterative version, we have this 14 lines of code. Effectively, actually, if you remove all the spaces and the comments, that's just like 1, 2, 3, 4. That's like 10 lines, okay? So you define a function, Fibonacci underscore iterative, all right, and it takes argument n. So then you initialize the sequence. So you open this list, empty list, and then you have the starting point a comma b, where a is 0 and b is 1. So for everything in the range n, right? And now have sequence.append a. So you keep append. So you first of all append a to that sequence that is 0, and then you now have a comma b. So your new a comma b now becomes the old b comma. So the new b will now be the sum of the old a and b. Basically, that's what this line 8 is saying. And then you return the sequence. So that keeps going like that. So you append 0. Then as you append the 0, automatically a and b now becomes the old b, that's 1. Then 0 plus 1. That's why you have another one. And it keeps going like that. So example usage, of course, you have number of terms. So you have to determine the number of terms you want. So maybe you want maybe 20 Fibonacci, 20, the first terms in the Fibonacci sequence. So number of terms, this line 12 is going to prompt you to impute the number of terms of Fibonacci sequence you want. And then you can now, so this line 13 prints the head in Fibonacci sequence. And then this final print actually prints the result of the what the function gives you. So Fibonacci underscore iterative then takes the number of terms and then it generates it for you. So for instance, so looking at what we had up here, right? This is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I want the first 8 terms, so it will give me up to 13, that is. So I run this now. So it gives me, so it will prompt me to type what I want. Enter the number of terms. I just type 8. And then, it gives me 0, 0, 1, 1, 2, 3, 5, 8, 13. Okay. Let me go to 20 now. So I run it again and I do 20. Okay, so the last term in 20 is 41881. Interestingly, I mean, there are many for number theorists, they have done a whole lot of work to look at this whole pattern thing and how it leads up to the golden ratio and things like that. Okay, let me take a very big number and see how far that goes. Let me take 100, right? 100 terms of Fibonacci sequence. Okay, that's plenty. You can be sure the number is so big already. So, I mean, this is more than billions, in fact. So that's what that looks like. So that's the iterative version. So we can also have a recursive version. So it's all about approaches. I mean, one thing you should already know about coding is that you may be able to do the same thing in in 5 or 6 different ways. At least that you have at least 2 ways of doing one thing. And at the end of the day, you may want to go for something that does the most efficient way, that takes less lines of code and takes less time to run, basically. But if you want to think about the recursive version of this, so Fibonacci sequence generator using the recursive version. So again, we define the function. We say Fibonacci underscore recursive, taking n arguments. So if n is less than or equal to 0, of course, n can be 0, right? So then return blank, all right? Else if n is equal to 1. Okay, sorry. If n is less than or equal to 0, that's not the number now, it's about the term. So the first term, so if n is less than or equal to 0, you return an empty list. But if n is equal to 1, then you return 0 because 0 is the first term. If n is equal to 2, then you return 0, comma 1. Those are the two terms now. Else, you can then have the sequence. So else sequence is now Fibonacci underscore recursive n minus 1. So you keep going. Then sec.append. So to that, you now have sec minus 1. That's from the back plus sec minus 2. So it's like this now plus this. And then it keeps going. So at the end of the day, you return the sequence. So example usage again, you put the number of terms. So enter the number of terms and then just go again. So now, except that we are doing recursive. So again, I do 8. We get 13 as the last number. I run again and maybe I want to go for 10. So we get 34. I want to go for, say, 20. We have 4181 there. Then I go for, say, 50. And we have the last number there. I think it's still a bit manageable. This is 1,000,000,000, billion. That's 7,778,742,049. That's still uh, we can still handle that, right? Of course, you can also do a bonus, like using a generator now. We can do a bonus using this generator. So you now say define Fibonacci underscore generator taking n. So you have a b 0,1 for everything in range n, then yield a. So it's like you output the a. So that's what generation means. So you output the A and then you switch over A and B like we explained before. So it's now come out as a list like that. So it's the same thing it's doing, but then it's coming out like one after the other. That's what the idea of generation is in Python. So if I do the normal 8, so it is going, so you see it's listing it like this. Then we go for the next one. So again, like I did 20 before, ending in 4181, and then I can do 50 now. 50 terms in it. So 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, 8 plus 13, 21, 21 plus 21 plus 34, 55, and so on and so forth. Now we can actually do the Fibonacci sequence plot. You can plot it. So here now, we want to plot and save it in CSV file, right? So what we're doing here is, because we want to plot, we need matplotlib.pyplot as PLT, then we import CSV also. So for the generator, which we just did there, so you have this. Then the main program now for plotting. Okay, of course, for number of terms, you enter the number of terms and you get the Fibonacci sequence thing. And then this is, so you have file name Fibonacci underscore sequence or CSV. So the numbers are generated and saved in CSV. So with open file name mode W new line as file writer CSV.writer file write. I mean, this helps to write into the CSV file basically. And then you have a Fibonacci sequence saved to whatever the file, this file name now, Fibonacci underscore sequence of CSV. Then to plot the sequence, so you have plot figure 8,5. So plot range, the number of terms, you have the number of terms on the x-axis, and you have the actual value of this for each term on the y-axis. All right. And then, that's the title is Fibonacci sequence, plot x label index n Fibonacci. So we can run this now. Okay, let me just run it using Control Enter. So now again, I have 8. So if you plot 8 now, see what it gives. You have you have the number generated, then it is already saved in CSV. If you come here, you see how it, so you see Fibonacci underscore sequence. So you can see that saved like that. So if I go back and do the 20 I did before, okay, run again, and I have 20. So, so you see this is extending, okay. So it's growing exponentially, as you can see. So yeah, we have 8 now. All right. Then imagine we have let me go to okay, let me do 100 straight because because we are saving the CSV file now. Or let me even do 1000. I know that's a lot. That's crazy, yeah. So you can see it has grown so fast that by the time we now go into the list, so we have this up to 1000. So or we can see 100 at a time. So you can imagine the 100th one. So if I go for the next 100, it's growing large. So let's go to the 1010. It's such a big number. But and that will help you appreciate the power of computing, right? So we do 1000 and it comes out in just about 4 seconds, right? So, we can easily download this Fibonacci thing now. We can download it, and then we see it in our downloads, how been able to generate 1000 terms in the Fibonacci sequence. So you see that if I take it to the end now, okay, the number is so large that we have it. That's the last number is like 2.68 times 10 raised by 208. That's such a big number indeed. All right, so this I come to the end of this video about how to use Python to code a Fibonacci sequence generator. That's pretty interesting. So, in case you ever have a need for this at one time, at some point, feel free to avail yourself of the opportunity. Okay, if there's something else you'd like me to try out, feel free to let me know. Now I've just made it into 100. Okay, so if you have subscribed already, I thank you so much for that. If you have not subscribed, of course, you want to go ahead and subscribe right away. All right, and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you want to become a member of the channel, feel very free. Okay, to do that, just click on join. I see 3 levels of membership with special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.